Let's find the maximum area of a rectangle that can be inscribed in the region between y equals negative 0.2 x squared plus 20, y equals x squared, and the x-axis in the first quadrant. Now, here's the diagram or the graph. The blue curve here is y equals x squared, and the red curve here is y equals negative 0.2 x squared plus 20. And here's the rectangle bounded by this two curves in the first quadrant in yellow. We have to find the maximum area of the rectangle here. Now notice that this question here, right? The rectangle is bounded by two curves, not just one curve. So it's more complex. So how do we approach this question here? Now, first of all, you need to think about what is the area of a rectangle. It is length times width. It seems like that the length here is represented by the x-axis, and the width here is represented by the y-axis. But this is not just simply x times y, because we're doing an optimization problem here. Notice that the value of the length and the width varies. They will change depending on where these 2 points are lying on the curves here. Well, if these 2 points here, this 2 point here, let's say they're lying here and here, right? Then this rectangle will have a shorter length but longer width. And if these 2 points are lying, let's say here and here, right? Then this rectangle will have a longer length but shorter width. But which one would give the maximum area of the rectangle? That's what we have to find out. Okay, so let's look at it this way. Since I just mentioned that the value of x and y may change, right? So it's not fixed right now. We have to find out what the value is. So let's call this this length here, let's call this delta x, right? It will change. And the value of y, we call this delta y, right? Because we don't know what the value of for each of them. That's what we have to find out right now. That will give the maximum area of the rectangle. So to come up with an equation of the formula of the rectangle for the area of the rectangle would be delta x times delta y. So the area of the rectangle here is delta x times delta y. Now, what is delta x and what's delta y? Now, let's look at delta y first. Now, notice that this rectangle will always sit on top of the x-axis here. Doesn't matter when it's higher or it's lower, right? So the start point is, for the y value, the starting point is always the origin, 0. And up to this point, the top here, what value is this? Okay, it's going to be a value here, right? A y value. We don't know what it is. So delta y is always coming from, always starting from 0 up to the y value here. Then we can say that delta y is equal to y minus 0, right? Then delta y is equal to y. That's it, okay? Next, look at delta x. What's the value of delta x? Now, notice that the rectangle does not start from the origin in the x-axis. So it's somewhere here, right? So the first value here, right? And the second value is here. And that's the value of the length here, right? Between these two values. Okay, how about this? This is the x value. The first x value, we call this x subscript 1. Right? So x1. And the second value here, we call it x subscript 2. So x2 here. Right? Again, because the x value does not start from the origin. So we have to look at it like this, right? This is the first x value and this is the second x value. So what's the value of delta x? It's going to be the value between x1 and x2. So we can say that delta x is x2 minus x1. So delta x is equal to x2 minus x1. So you can rewrite this area formula, right? Basically, delta x is x2 minus x1 times delta y is just y. Okay, so that's the area of the rectangle. And of course, we cannot just work with the equation like this, right? It has x value and the y value like this, and we don't even know what they are, right? So what do we do next? Now, it seems like it's easier just to convert everything into rewrite everything in terms of y. So rewrite x in terms of y. We can do that. But let's look at how we do this. Now we do have two equations here, right? So this point here, so this x1 is basically the x value in the blue curve here, right? So y equals to x squared, right? And this x value here is basically the x value in the red curve here. So we can rewrite this two functions, right? These two equations, two functions. Then you can see what I'm saying. Okay, so since x1 value lies on the blue curve, we will rewrite this function as y equals x subscript 1 square, right? So let's rewrite it like that. So y equals x subscript 1, right, square. And the second x value lies on the red curve, the second curve here. So this x value is basically x subscript 2, x2, right? So we can rewrite this function as y equals to negative 0.2 x subscript 2 square plus 20. So y equals to negative 0.2 x subscript 2 square plus 20. Okay, so now we have our x2 and x1. So we have to rewrite a function in terms of x2 minus x1. What do we do? Okay, we just need to isolate x1 in this equation and isolate x2 in this equation, right? Okay, so in this case, basically, let's write it like that, right? x1 square is equal to y. Then take the square root of both sides. You have x1 equals to square root of y. Now let's take the positive value, okay? When you take the square root, it could be positive and negative, but let's take the positive because it's in the first quadrant, right? On the graph, it's positive. Okay, so this equation here isolate x2. So we have to, let's say, subtract 20 from both sides. Y equals to, okay. Let's do it like that. Y minus 20 is equal to negative 0.2 x2 squared. Divide both sides by negative 0.2. You get, okay, so 1, basically 1 divided by 0.2 would be 5. But this is negative, so this becomes negative, right? So 20 to negative 20 divided by 0.2, 100. So we have 100 minus 5y. Now this is x2 squared. Now take the square root of both sides, right? We get x2 equals to square root of 100 minus 5y. Okay, so now we have x2 in terms of y. We have x1 in terms of y. We can just replace x2 and x1 into this formula here. And then we have everything in terms of y, right? That's how we should do it. Okay, so let's carry from here, right? So the area of the rectangle is, now x2 is this, square root of 100 minus 5y minus x1 is basically square root of y. Let me write it better. Times y. Okay, see? We have everything in terms of y now. Okay, now let's distribute it. So the area of the rectangle is this times this. We have y times square root of 100 minus 5y minus y times square root of y. Okay, now what do we do? we have to take the derivative of the area with respect to the y value and then set it equal to 0 to find out what is the y value that will give the maximum area of the rectangle. Once we have the y value, we just have to put it back into the equation here, right? And just get the x value, then we can find out the area, the maximum area of the rectangle bounded by these two curves. So the next thing is take the derivative of the area with respect to the y value, right? Okay, so apparently this one here is a product of two functions. So we have to use the product rule, right? It's y times square root of 100 minus 5y. Now let's look at it like that. Here. Let's do the first part first, okay? Derivative of y, derivative of area with respect to y is just 1. So the first part is 1 times square root of 100 minus 5y, right? Plus y times the derivative of the square root of 100 minus 5y, okay? So what is that? So look at it like that, right? So let's see, right? Square root of 5y. The square of 100 minus 5y is the same as 100 minus 5y to the power of 1/2, right? Okay, when you take the derivative, you have to use the chain rule, right? Because this is a function here. It's function inside another function to the power 1/2. Okay, so let's do it that way. Okay, so let's let g equals to this function, and I will let u equals to, let's say, 100 minus 5y. Okay, then g is basically equal to u to the power 1/2, right? Because now u is equal to 100 minus 5y. According to the chain rule, I will take the derivative of u with respect to y. So du over dy here is just -5. And then next, I will take the derivative of g with respect to u. So dg over du, that will be equal to 1/2 times u to the power of -1/2, right? Subtract 1 from the power. And that is the same as 1/2 square root of u. And u is equal to 100 minus 5y. So I have to rewrite this. 1/2 times square root of 100 minus 5y. Okay, so that's dg over du. And if I want to find the derivative of 100 minus 5y all to the power of 1/2, right? I'm taking the derivative of g with respect to y. So dg over dy. That's what I'm looking for. According to the chain rule, this is equal to dg over du times du over dy. Right? Because when du and du cancel out, all you have left is just dg over dy. And what's that equal to? dg over du is here, 1/2 times square root of 100 minus 5y. So that's 1/2 times square root of 100 minus 5y times du over dy is -5. So that is just equal to -5 divided by 2 times the square root of 100 minus 5y. Okay. And what is that equal to? Okay, so we don't need this anymore. This is just my work of doing the derivative. Okay, so now it's just equal to y times derivative of this, y times this, right? -5/2 times square root of 100 minus 5y times -5/2 times the square root of 100 minus 5y. Okay, minus, right? What's the derivative of y times square root of y? Now, y times square root of y, right? Y times square root of y is the same as y times y to the power of 1/2, and that's equal to y to the power of 3/2. So when you take the derivative, right, it's basically 3 over 2 times y, and then minus 1 from the power. From here, you get 1/2. Okay. Now, let me erase all this. Okay, let's continue from here. Well, let me think like that, right? Let's do this. Derivative of a with respect to y, right? So this will be the same. Minus 5y. Now plus, well, let me do this. Just put in minus, right? Because plus minus is just minus. 5 over 2y. So I will move the 2, constant 2 up here, and then times y, right? All divided by square root of 100 minus 5y. Minus, this will be 2. Okay, 3 over 2. Right? It's 3 over 2. So 3 over 2 square root of y. Okay. Now, what do I do? Now, I have to set this equal to 0, right? So let that equal to 0. Square root of 100 minus 5y minus 5 over 2y divided by square root of 100 minus 5y minus 3 over 2 square root of y. Okay. The next thing what we want to do is maybe we can find the common denominator of all this term and then just group it together, right? And of course, right, when you multiply the square root of 100 minus 5y by square root over square root of 100 minus 5y over square root of 100 minus 5y, right? You get this 100 minus 5y divided by square root of 100 minus 5y. So that is the same as this. Okay, minus 5 over 2y. Let's work with decimal so that I guess will be easier later on, right? Instead of fraction. 5 over 2 is just 2.5. So 2.5y over square root of 100 minus 5y, right? Minus, okay, if you multiply this one by square root of 100 minus 5y over square root of 100 minus 5y, you get 3 over 2 is just 1.5, okay? Square root of y times square root of 100 minus 5y over square root of 100 minus 5y. Okay, so now we can group this together. Equals to, now, this is 100 minus 5y minus 2.5y minus 1.5 square root of y times square root of 100 minus 5y. All divided by square root of 100 minus 5y. What do we do next? Okay, we can get rid of the fraction. We can get rid of the fraction, right? Basically, get rid of the denominator. So we can multiply both sides by square root of 100 minus 5y. So 0 times this, right? 0 times square root of 100 minus 5y is 0. So 0 is equal to, now this top here. Let's simplify this, right? So this here is basically minus 7.5y. Then minus, okay, 1.5 square root of y times square root of 100 minus 5y. Now, this is square root times square root. So when you do that, it's basically the same as this. 1.5 times square root of y times 100 minus 5y. So it's the same as this. And of course, we can distribute this, right? So we have 0 equals to 100 minus 7.5y minus 1.5 times square root of 100y minus 5y squared. Okay. Now, how do we solve this? Now, we do know that, right? This is just y and that's a square root here. What we can do is isolate this term, right? Let's move this one to the left side as it's one term, okay? So add 1.5 times square root of 100y minus 5y squared on both sides. We have 1.5 times square root of 100y minus 5y squared is equal to 100 minus 7.5y. Why did I do that? Well, now it's easy because that's just one term here. I will square both sides, right? Squaring this side is easy too, okay? So 1.5 times square root of 100y minus 5y squared. Well, take the square, right? So now this is 100 minus 7.5y all square. Okay, so if that's equal to this, then square both sides will still equal, right? Okay, so what is this side now when you square it? Okay, now 1.5 squared is 2.25. So basically 2.25 times, when you take the square of the square root, right? You basically get rid of the square root. So 2.25. Okay, here. (2.25) times 100y minus 5y squared. So that's the left side. Now what is the right side? Now the right side is basically this: 100 minus 7.5y times 100 minus 7.5y, right? Okay, so let's distribute this. 2.25 times 100y is 225y minus 2.25 times 5, 11.25 y squared. Now what is the right side? Now we do know that 100 times 100 is this is 10,000, right? 100 times 7.5y is 750y, and 7.5y times 100 is 750y. So two of this together, now 750 times 2, oh, 1500y, right? And then this negative 7.5y times negative 7.5y is 56, now plus 56.25 y squared. Now we can just rearrange the like term, okay? Right? So what do we do now? Let's move all this to the right side, okay? So when you move 225y to the right side, you're subtracting it. Okay, and when you move the negative 11.25y squared to the right side, you are adding it. Okay, so 56.25y squared plus 11.25y squared is 67.5 y squared. And when you subtract this, right, 225y, you're basically subtracting 1725y, right? The constant's still the same. So that side will be equal to 0. Okay, now you have a quadratic equation. How do you solve for y? Well, to make it easier, let's use the quadratic formula, okay? So the quadratic formula is basically equal to this, right? So y is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so a is 67.5. B is 1725, and C is 10,000. Okay, let's do this. So y is equal to negative 1725, right? Plus or minus square root of b squared would be this, negative 1725 square minus 4 times a is 67.5 times c is 10,000. All divided by 2a, 2 times this, 67.5. Okay, let's do this. Y is equal to, this is positive, right? Plus or minus, so what would this be? 1725 squared, 1725 squared minus 4 times 67.5 times 10,000. So it's basically this number here. Now square root of all divided by, what's 2 times 67.5? 135, okay? Well, let's take the square root of this. We'll see if we can get a whole number, like the integer. Yeah, we can. So y is equal to 1725 plus or minus 525 divided by 135. Okay, so that's like 2y value. Okay, let me write it here. Okay, one of them would be y equals to 107.25, right? Plus 525 all divided by 135. And the other one is, right? I'm going to write this or y equals to 1725 minus 525 divided by 135. Now let's calculate this. That one is 16.6667. Let's use 4 decimal for now. Or y equals to 1725 minus 525, right? Divided by 135. 8.8889, okay? Round it up. Okay, so we have two y value. But I think only one of them will give the maximum area of the rectangle. Which one is that? Okay, so now come back to the original graph here, or the diagram, right? If you look at it, right, this rectangle will always stay within this region, right, between these two curves. So that means the y value here, right, that's the y value, the width, right, it should never pass this intersection point of the two curves, okay? So it should never get past this point, right? So now what we need to do now, what we should do now is to find out what's the value of y here at intersection of the two curves. How do we do that? We just put these two equations, right, and set it equal to each other. So let's do it like this. So we have x squared, right, the first equation equals to this equation, equals to negative 0.2 x squared plus 20. Okay, so if you move the x squared, right, this one to the right side, you add 0.2 x squared. So it's 1.2 x squared equals to 20. Now, x squared is basically equal to 20 divided by 1.2, which is 20 divided by 1.2. So it's around 16.6667, right? Then, of course, right, you take the square root of this. X is equal to square root of 16.6667. Okay, so here's the thing. I will keep x squared as 16.667 because why? I can just put this back into this equation here, right? This x squared into this equation. Then I have the y value, right? Because I can just put the x value into either of this equation. I will still get the same y value. So the intersection point, right? Intersection. Y value is equal to basically y equals to x squared, so y equals to 16.6667. So that's where the intersection point is. That means the y value can never go beyond this value, 16.6667. Okay, now let's go back to the two solutions we have. Okay, so we have y equals to 16.667 and y equals 8.889, right? Can you use y equals 16.6667? Well, it didn't go beyond the intersection, but it's right at the intersection here, right? It's just right at this point, the y value. Would that work? I don't think so, because if this is where the y value is, that means this rectangle doesn't have a length. When there's no length in a rectangle, you don't have a rectangle. So we cannot use y equals to 16.667. The other one is y equals to 8.8889, right? So it's falling within this region, okay? So maybe that's the y value we have to take, right? Y equals to 8.8889, right? We take this value, okay? Okay. Now, we have the y value, right? Here, where the y value. Then we have to figure out the x2 and x1. Then we can find the maximum area of the rectangle bounded by these two curves above the x-axis. To find x2 and x1, right? We just have to put the y value we just calculated, 8.8889, into the y here. We can calculate x1 and put it into the y here. We get x2. Okay, that's it. Okay, so let's calculate this, right? So y equals to x1 squared, and the other function is y equals to negative 0.2 x2 squared plus 20. And of course, we do know that y is 8.8889. That will give the maximum value of the maximum area of the rectangle. So that's x1 squared. So x1 is basically the square root of 8.8889. Then x1 is, what is that? Square root of 8.8889. 2.98. Okay, let's just keep it as 2 decimal, okay? Now x2 here. We will let y equals to 8.8889 of what we calculated, right? And what we figure out. Negative 0.2 x2 squared plus 20. Isolate x2 squared, right? So subtract 20 from both sides. 8.8889 minus 20 is equal to negative 0.2 x2 squared. Now, 8.8889 minus 20 is negative 11.1111, right? It's equal to negative 0.2 x2 squared. Divide both sides by negative 0.2. We have 55.5555 equals to x2 squared. And of course, right? x2 squared. And then we take the square root on both sides. Take the square root of this, right? 55.5555. Okay, let me write better. What do I have? Square root of 55.5555 is 7.45. Okay, let's take 2 decimal for now. And now we have x2 and x1 calculated. Come back to this formula here, right? The area, the maximum area of the rectangle is x2 minus x1 times y. So area, what we call max, okay, is basically equal to x2 minus x1 times y. And x2 is 7.45 minus x1 is 2.98 times y. Y is 8.8889. 8.8889. Okay, well, let's round this up to 2 decimal, okay? 8.89, okay? Then, what's this? 7.45 minus 2.89 times 8.89. Okay, so it's around 39.74. Right? Unit square, because this is area, right? Okay, so this is the maximum area of the rectangle, bounded by these two curves and above the x-axis. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.